Hi everyone, this is a video on how we rationalize surds. Surds are things like square root of 2, square root of 3, etc. That we cannot write them as fractions. And normally in maths, the practice is that if we have a surd in the denominator of a fraction, we want to rationalize that, i.e. we want to get rid of the square root. And the way it's done is that we take the square root and we square it, i.e. we multiply it by itself, which square root of 2, which is squared, becomes 2. Square root of 3 when squared, let me write this again, square root of 3 when squared becomes 3. Or you could have even things like cube roots of something. Cube root of, say, 4, that's a surd. If I raise it to the power 3, I end up with 4. So basically, rationalizing a fraction is when we want to get rid of the surd in the denominator. And we normally deal with square roots, I think, for our purposes. So if I start, like everything else in maths, we do everything by way of examples to give us enough practice. But the simplest situation of a denominator with a surd is things like, say, 1 over square root of 5, say. And we want to rationalize the denominator. So when we rationalize this, we want to multiply both the top and bottom of this fraction by a number which squares the denominator, which is obviously would be the square root of 5 itself. So if I multiply the denominator by the square root of 5, obviously I have to multiply the numerator by the same number so that the fraction doesn't change. So then this will be equal to 1 times square root of 5, which will be square root of 5. And the denominator would be square root of 5 times square root of 5, which is square root of 5 squared, which will be just 5. So this is the result of rationalizing 1 over square root of 5. This is what we do. In general, if our surd is of the form 1 over root a, and we assume square root of a is a surd, we just multiply top and bottom by square root of a, and we get square root of a over a. Another example, let's look at, say, 4 over square root of 3. This will be equal to 4 times square root of 3 divided by root 3 times square root of 3, which will be 4 over 4 square root of 3 divided by 3. Let's look at another example. For example, I could have 12 over square root of 3. Now to rationalize this, we obviously multiply top and bottom by square root of 3. So the numerator becomes 12 times square root of 3. The denominator will be square root of 3 times square root of 3, which will be 3. Now here, you have to be aware that although we've rationalized the denominator, this fraction is not in its simplest form. So we have to always watch out to see if there's any common factors between the numbers in our numerator and denominator. So here, 12 and 3, they have a factor of 3, so they can divide by 3, both of them. So this becomes 4 square root of 3. Another types of surds that we might get in our denominator is when our denominator is an expression. For example, if I have 4 over 1 minus root 2, how will I rationalize this? For this, we will need to be reminded of an identity, which I think it's called the difference of two squares. If I have a squared minus b squared, where a and b could be any numbers, this can be written in the form of a minus b times a plus b. Also, the reverse is true. A minus b times a plus b can be written as a squared minus b squared. So we use this information to rationalize this. So if I look at my denominator in the form of 1 minus square root of 2, and if I imagine 1 is the same as a in this identity and square root of 2 is the same as b, I will multiply the top and bottom of this fraction by 1 plus square root of 2. So our fraction becomes 4 bracket 1 plus square root of 2, and the denominator becomes 1 minus square root of 2 times 1 plus square root of 2. Now this will be, you may or may not require to multiply the 4 into the bracket, but for the moment we do need to do that. So I'm going to just leave the 4 outside the bracket. So this will be 4 times 1 plus square root of 2. Now this 1 minus square root of 2 times 1 plus square root of 2 becomes 1 squared, I keep them in bracket, minus square root of 2 squared, according to this identity here. And then this will be reduced to 4 bracket 1 plus square root of 2. And the denominator will be 1 squared is 1. Square root of 2 squared is square root of 2. So it will be 2, sorry. So this will be 4 1 plus root 2 divided by minus 1, which will be equal to minus 4 1 plus root 2. So basically, in all these type of situations, we multiply the denominator, like in the form of a minus b, and we multiply it by a plus b, or if it was a plus b, we would multiply it by a minus b. We'll do some more examples. Okay, let's do another example. As you can see, I have now put our identity in this red box so that we can refer to it as we need. So let's say I have 6 divided by, let's say 2 plus, let's use a larger number, sorry, 4 plus square root of 2. Now to rationalize this, I have to multiply top and bottom of this fraction by 4 minus square root of 2. So this will become 6 times 4 minus square root of 2. And the denominator will be 4 plus square root of 2 times 4 minus square root of 2. This will become, I can keep the 6 outside the bracket. That would become 6 bracket 4 minus square root of 2. The denominator will be 4 squared, which will be 16, minus square root of 2 squared, which will be 2. So this will be 6 bracket 4 minus square root of 2 divided by 14. Again, here we must watch out. Is there a common factor between 6 and 14? There is, because they're both even numbers. So this can be written as 6 divided by 2 is 3, 14 divided by 2 is 7, and this will be 4 minus square root of 2. Now you can write this at 12 minus 3 square root of 2 over 7, or we can leave it as 3 bracket 4 minus square root of 2 close bracket over 7. They're equivalent statements. You can even have situations then when you have a square root in the numerator, like if I have, say, square root of 17 over 3, I'm just throwing this as a number, I haven't given it much thought. This obviously we can write this as square root of 17 divided by square root of 3. And to rationalize this, we just multiply top and bottom by square root of 3. So this will be equivalent to square root of 17 times square root of 3 divided by square root of 3 times square root of 3. And this will be equal to square root of 17 times square root of 3 is the same as taking both numbers under the square root. So it's 3 times 17, which becomes 51. And square root of 3 times square root of 3 becomes 3. So that's rationalizing fractions where the numerator may have a surd in it. The surd in the numerator is not an issue. It's important that we get rid of the surd in the denominator. Here is another example. Let's say I have square root of 6 divided by square root of 3. Incidentally, this is the same as square root of 6 over 3, i.e. square root of 2. But I'm trying to highlight an important issue here. If we rationalize this in the normal way, this would be square root of 6 times square root of 3 divided by square root of 3 times square root of 3. And this will be square root of 18 over 3. And the point I wanted to highlight here is that when we have a square root of 18, if we want to continue to simplify the fraction, we must watch out to see if this number under the square root can be factorized, and does it have a factor which is a whole square. Okay, this can be written as square root of 9 times 2 over 3. Now, square root of 9 times 2 is the same as square root of 9 times square root of 2. We'll have a 3. And square root of 9 is 3. So this will be 3 root 2 over 3. And the 3's cancel, which gives us square root of 2, which would be the same as if I had divided this 6 by. So the reason I wanted to highlight this example was to see that if we end up with a square root in the numerator, with a number that can be factorized, we have to check to see if there is a square factor that can come outside the square root. Finally, we have situations where we have surds in the numerator and the denominator. How do we tackle these? Let's look at an example. Let's say I have 6 plus square root of 2 divided by 8 minus square root of 2. How do I rationalize this? Well, we do the same thing. We use this identity in the red box to rationalize the denominator, which will mean I have to multiply both numerator and denominator by 8 plus square root of 2. Always remember, whatever the sign is in the denominator, if it's minus, then we multiply by the same two terms but with a plus in between. So this would be 8 minus square root of 2 will be times 8 plus square root of 2. Okay, what we need to do now is to expand the brackets, multiply it out. So 6 times 8 is 48. Then we have plus 6 root 2. Then I have plus 8 root 2. That's root 2 times 8 will be 8 root 2. Then I have root 2 times root 2, which will be just 2 by itself because that will be root 2 squared. The denominator will be a squared, which is 8 squared, which is 64, minus square root of 2 squared, which is 2, comes minus 2. Now, we add like terms. 48 gets added to 2, which becomes 50, because I have a 48 here, and I have a 2 here on its own, 50. And here I have 6 root 2's and 8 root 2's, they become 14 root 2. Square root of 2. And here in the denominator, I have 64 minus 2, which will be 62. Okay, we now need to see if this expression can be simplified. Obviously 50 and 14, they're both even numbers. I can get a factor of 2 out of this, so this will become 2 bracket 25 plus 7 square root of 2, and here I have 62. So 62 is even, divided by 2 becomes 31, so this will reduce to 25 plus 7 root 2 divided by 31. I hope you found this useful. Please click on the subscribe button and give it a like if you found it useful, that is. And I see you in the next video. Thanks.